What's up, mathematicians? This is Mr. Bergman here, coming to you with section 3.62 using the quadratic formula and the discriminant. What is the discriminant? I'll tell you what it is. It is here, the contents of the square root in the quadratic formula. That's that b squared minus 4ac. X equals negative b plus or minus the square root of the discriminant. B squared minus 4ac all over 2a. So, here's the big idea. I'll get to it real quick. The contents of the square root in the quadratic formula, that is the discriminant, determines the number and the type of solutions. So, let's say you had two real solutions. That must mean that when you were taking the square root inside the quadratic formula, b squared minus 4ac, when you found out all that, it must have been a positive number. If you have a positive number inside the square root of the quadratic formula, then the solutions will be two real numbers eventually. You're not going to have any imaginary or complex solutions. I will not be present, like the imaginary number I. It's not going to be there. Here's a sample of the related equation. So the graph could look like this. You can see those two x-intercepts are going to be two different real numbers. Now let's say that the contents of the square root in the quadratic formula were 0. If that were true, then it would be x equals negative b plus or minus square root of 0, which is just 0. So plus or minus 0, it just drops out. It's going to be negative b over 2a. You're going to have one solution. The graph will look like this. It'll have the vertex on the x-axis, and there will be only one solution, and there it is, that vertex. Now, if you get a negative inside the square root, then you know it's time for imaginary time or complex numbers time, and you get negative b plus or minus the square root of a negative number. There will be 0 real solutions, and we can call those two non-real solutions. You know what they look like. It's like 3 plus or minus 4i, or 6 plus or minus 2i, or something like that. Those are not numbers that you can graph on the xy plane. There will be no x-intercepts, and if you're trying to look for x-intercepts on a graph like that, they're not going to be there. This parabola could be way up here, or it could even be down here. It's just not going to be touching the x-axis. So that's kind of what we're looking at here. So let's do some example problems. It says, find the value of the discriminant, b squared minus 4ac, for each quadratic equation. Then describe the number and type of solution for the equation. So let's say you had x squared minus 8x plus 16 equals 0. Well, this a is equal to 1, b is equal to negative 8, c is equal to 16. So you calculate b squared minus 4ac. Careful to keep that negative inside parentheses. This is 64 minus 64 is 0. You get one real solution. So if you were to actually use the quadratic formula, you get x equals negative b plus or minus the square root of 0. All that drops out. You're only going to have one real solution. If you were going to graph this, y equals x squared minus 8x plus 16, it would look something like this, where the parabola only touches the x-axis once. To generate it'll have one x-intercept, and the corresponding equation only has one real solution. Contrast that with this, x squared minus 11x minus 26 equals 0. A is equal to 1, b is equal to negative 11, c is equal to negative 26. You get negative 11 squared minus 4 times 1 times negative 26. Both of these turns into positive numbers, and you add them up, you get 223. You take the square root of 223. I'm not sure what it is exactly, but it's a real number. So you're going to have two real solutions. We're not concerned about what the real solutions are. We're just looking to do a quick and dirty, analysis of what category are we in. Are we going to be in two real solutions, to one real solution, or 0 real solutions, or complex solutions? And that's all it'll look like. The easier questions on alex.com will just be like, how many solutions are there? You'd be like, oh, there's 2, or there's 1, or there's none. So here's how it could look a little bit harder, and this is taken straight from the SATs. For which values of p will 2x squared minus x plus p equals 0 have two real solutions, or one solution? Here's just another example of them taking a normal skill, like finding the discriminant, like we just did, and asking you to kind of move forward, even though there's a letter where you expect there to be a number. And so we're going to do the exact same thing we did before. We're going to have a squared plus minus b squared minus 4ac, and then we're also going to attach a condition to it. if there's going to be two real solutions, then that means that all of this, whatever it is, has got to be greater than 0. That's what we want. We're attaching a condition, an ending condition to this, that if this is going to be, we want it to have, we're going to force it to be two real numbers, so that the b squared minus 4ac has got to be positive. What does it mean to be positive? That means greater than 0. So whatever p is, I don't know what it is, but apparently all this has got to be greater than 0. If you kind of do the math and move this over to the other side, adding 4 times 2 times p to both sides, you get 1 is greater than 8p, and therefore p has got to be less than 1/8. It can be any number you want, just as long as it's less than 1. It could be like any negative number. It could be 1/16. It could be 0. P is 0. If you make p equal to 0, then this will have two real solutions. What about if we wanted to force it to have exactly one solution? Well, if it's going to have one real solution, as we can see in the table, one real solution means that the discriminant has got to be exactly equal to 0. And, when we graph the related equation, it would just barely touch the x-axis once at this one point. One x-intercept corresponds to one solution. So this is b squared minus 4ac. It's all equal to 0. And we can solve this the same way. Get p is equal to 1 over, and I'm going to let you figure out what that is. I'm also going to kind of drop in the comments right now the fact that I'm actually recording this after school has already let out. I had a recording that I liked, it was okay, it was fine, but I like what I'm doing now. And so it's a huge improvement, and I hope you enjoy it. I'm recording this over the summer. So I hope you all have a great summer when you get to summer, and I'm sure you will. So tell me, when you come back in the class tomorrow, tell me what's your favorite thing to do over the summer, and I'll tell you what mine is. Take care, and I'll see you in class.